Hi, this is Bill from TutorBros. Today I want to go over how to convert an IPv4 address from binary to dotted decimal notation. So as you can see, this address is in binary form. So just a quick little background, IP stands for Internet Protocol. Every device that's connected to the internet is assigned an IP address. An IP address consists an IPv4 address consists of 32 bits, which is the smallest unit of data for a computer, or 4 bytes, BYTES. And so 1 byte equals 8 bits, and a bit, again, is just the binary ones or zeros that's listed out here. And each byte is separated by this dot here. So you can see there's 3 dots. Between each dot is 8 bits or 1 byte, and binary form is readable by computers. A simpler version that's readable by humans is dotted decimal notation, which is what we're going to convert it into, and that's readable by humans, and we convert them 1 byte at a time. So I will rewrite the first byte, and I'll leave some space in between each number. Okay, now above each binary 1 or 0, I'm going to assign a value. And we'll start at the right and go to the left. And this value, we will sum together if any binary 1 is associated with it. So this is how you convert it from binary into DDN. So from the right, we'll assign the first spot 1. We'll assign, going to the left, we'll assign the next spot a value of 2, and then we'll just keep doubling it from right to left. So 2 doubled is 4, double it 8, 16, 32, 64, and 128. So again, the rule is we want to look at the top numbers, and we're going to sum all the top numbers where the number beneath it, which is a binary 1 or 0, we will sum the numbers that have a binary 1 associated with it. So the first binary 1 I see on the very left is 128. The next one that has a 1 associated with it is 64, and then the rest are zeros. So we will sum these two numbers, and we get 192. And this byte in binary form is equivalent to 192 in DDN form. So you'll notice that in DDN, the values can range from 0 to 255. So it should fall within that range when we're converting. If it's outside of that range, that means something went wrong. So we will go to the next byte. So we have 4 bytes to do in total. The second byte, I'll just write right underneath 1 0 1 0 1 0 0 0. And again, look at the topmost values up here. And then we will now look at the third line. And everything that has a binary 1, we're going to sum the numbers at the top. So 128 has a 1, plus 32 has a 1 associated, plus 8, and the rest are zeros. So this total is 168. So I'll rewrite that over here as 168. So for that second byte, it has a DDN value of 168. Now let's write the third byte, 0, 0, 0, 0, 1, 0, 1, 0. So again, the third line, sum all the numbers at the top with a binary 1 associated with that line. So the first number is here, so that's an 8. We sum this number, so 2, we get 10. So on the third line here, I will write a 10. And then I will write the fourth byte right underneath, and it's all zeros except the rightmost value is 1. So the value at the top that we're going to sum, and the only value is 1. So this is 1. So to rewrite these 4 numbers that we got in dotted decimal notation is 192. And this similarly is separated by dots, where the binary ones and zeros are 8 of them are separated by a dot. The each DDN value associated per byte is separated by a dot. So 192, 168, dot 10, dot 1. So this value here is an IPv4 address in dotted decimal notation form. It's more readable by humans. It may be more recognizable to you as compared to this binary form. The binary, it's readable by computers. It's easier. This is how computers intake the information. The IPv4 address in DDN here is obviously easier for humans to read. So that is how you convert an IPv4 address from binary into DDN.